Right now, as you are listening to this, cholesterol is moving through your body. Not as a number on a lab report, not as a diagnosis, but as living particles traveling through nearly 60,000 miles of blood vessels. Some of those particles glide smoothly, others drift closer to arterial walls, and a few begin a slow, silent interaction with the lining of your arteries. Now imagine you stand up and take a few steps. Not a workout, not a commitment, just movement. Within minutes, something shifts. Not months later, not after weight loss, during the walk itself. Most people believe walking burns calories or strengthens the legs. Almost no one is told what it does to cholesterol in real time. Not the chemistry, not the timing, not the intelligence of the response. If you have ever been told your cholesterol is high and left wondering what that actually means for your body, stay with me. Because what happens during a simple walk reveals something most medicine never explains. Pause. This is not a story about fighting cholesterol. It is a story about teaching your body how to manage it. Cholesterol has been misunderstood for decades. It is often framed as an invader when in reality it is a raw material. Your liver produces close to 1,000 milligrams of cholesterol every day, not because it is malfunctioning, but because cholesterol is essential for survival. It stabilizes cell membranes. It allows hormones like estrogen and testosterone to exist. It supports brain signaling and nerve insulation. Without cholesterol, there is no life. The real challenge is that cholesterol does not dissolve in blood. So your body packages it into transport particles called lipoproteins. These particles are not good or bad by nature. They are tools. Low-density lipoproteins deliver cholesterol to tissues that need repair or growth. High-density lipoproteins collect excess cholesterol and return it to the liver. Problems arise not from cholesterol itself, but from how these particles behave under certain metabolic conditions. Inflammation, insulin resistance, prolonged inactivity. Cholesterol is not the villain. It is a passenger responding to the environment you create. Nearly half of all heart attacks occur in people with cholesterol levels considered normal by standard blood tests. This is not speculation. It has been documented repeatedly in large population studies. The reason is simple but rarely explained. Total cholesterol does not describe particle behavior. Two individuals can have identical cholesterol numbers. One carries large, buoyant particles that circulate efficiently. The other carries small, dense particles that penetrate arterial walls more easily and provoke inflammation. Standard tests measure quantity, not quality. Your body adjusts particle size and density in response to metabolic signals. Signals created by how often you move, how frequently insulin spikes, and how much inflammation is present. Cholesterol numbers are not commands, they are reflections. And one of the fastest ways to change those reflections is movement, specifically walking. The moment you begin walking, your muscles contract and demand energy. Glucose is used first, but within minutes, fat becomes a major fuel source. This demand activates lipoprotein lipase, an enzyme anchored along the inner walls of blood vessels. Its role is precise. It extracts fatty acids from passing lipoprotein particles and delivers them directly into muscle cells for oxidation. As this happens, LDL particles lose lipid content and change shape. They are no longer idle carriers. They are being metabolized. At the same time, HDL activity increases. Walking enhances enzymes that allow HDL to bind and collect cholesterol more efficiently from peripheral tissues and arterial walls. Within 10 minutes, two parallel processes are underway. Delivery particles are being emptied. Cleanup particles are accelerating. This is not theoretical. These shifts have been observed within hours of light to moderate activity. Your bloodstream becomes a working system instead of a storage channel. As walking continues, blood glucose begins to decline slightly. Not enough to cause fatigue, just enough to alter hormonal signaling. Insulin secretion decreases. This matters more than most people realize. Insulin promotes fat storage and suppresses lipoprotein lipase activity. When insulin remains elevated, cholesterol handling becomes inefficient. Walking lowers insulin and removes that brake. fat oxidation increases, triglyceride clearance improves. Hormones such as glucagon and adrenaline rise gently, signaling the liver to release stored energy rather than produce more. This is why post-meal walking is uniquely powerful. It intercepts lipid and glucose surges before they can be stored or repackaged into harmful particles. Timing matters, and walking aligns perfectly with human metabolism. Longer walks initiate a quieter and more powerful transformation inside the bloodstream. As movement continues, the liver receives a different signal, one that shifts how it produces HDL particles. New HDL enters circulation, but the real change is not the number, it is the function. Walking enhances HDL's ability to perform reverse cholesterol transport, the precise biological process that pulls excess cholesterol out of arterial walls and delivers it back to the liver for recycling. This is not cosmetic improvement. It is a functional upgrade at the molecular level. Not more trucks flooding the road. Better drivers navigating the system with greater efficiency. Over time, these HDL particles become more anti-inflammatory and more protective, stabilizing vessel walls and reducing the conditions that allow plaque to form. Studies show this effect appears in both middle-aged and older adults, even without weight loss or dramatic fitness gains. Movement does not just change cholesterol levels. It trains cholesterol behavior. Beyond the 30-minute mark, walking begins to change what your body chooses to burn. Muscles start pulling more energy from fat stores, including visceral fat, the deep fat wrapped around vital organs. Unlike surface fat, visceral fat is metabolically active. It releases inflammatory molecules that disrupt cholesterol handling and quietly damage the inner lining of blood vessels. As walking continues and visceral fat is gradually reduced, systemic inflammation begins to fall. When inflammation drops, cholesterol particles behave differently. They become less likely to embed in arterial walls and more likely to circulate safely. This shift has nothing to do with appearance. It is about internal signaling. As inflammation quiets, the liver no longer receives emergency signals to overproduce LDL. The body moves out of defense mode and into efficiency. Walking does not attack fat. It silences the biological alarms that made fat necessary in the first place. For decades, medicine assumed that only vigorous exercise could meaningfully improve cholesterol. Running, cycling, intense training were seen as the threshold for change. Then, large population studies began to reveal a quieter truth. Moderate walking produced cardiovascular risk reductions nearly identical to running, even when pace remained slow. What mattered most was not speed, but distance and consistency. Gentle, repeated movement activated the same metabolic pathways that regulate lipid handling, insulin signaling, and inflammation, without triggering stress hormones that can elevate cholesterol and strain the system. Walking worked not because it pushed the body to extremes, but because it worked with biology instead of against it. Walking is sustainable, and sustainability is what biology responds to best. The body adapts most efficiently to signals it receives again and again, signals that communicate safety rather than threat. The walk ends, but the biological signal does not. Long after your steps stop, the body continues responding. During rest and sleep, the liver begins adjusting how it produces and packages cholesterol. Fewer LDL particles are assembled, triglycerides are processed more efficiently, and lipid traffic through the bloodstream becomes more organized. Within weeks, these changes appear on lab reports, showing modest drops in LDL, improved triglyceride levels, and healthier ratios. But those numbers did not cause the improvement. They simply revealed it. The real work began during the very first walk, when enzymes activated, hormones shifted, and metabolic priorities changed. Blood tests capture snapshots. Walking changes the environment. It does not wait for permission from lab results or medical confirmation. It reshapes cholesterol handling immediately, step by step, at the level where biology actually makes decisions. Your body is not broken. It is responding to the signals it receives every day. High cholesterol is not a betrayal or a failure of will. It is an adaptation to a world that rarely moves and constantly asks the body to stay on alert. Sitting for hours, chronic stress, and artificial urgency all send the same message: prepare, store, defend. Walking sends a different signal, a signal of safety, a signal of capacity. When you walk regularly, you tell your biology that energy does not need to be hoarded, and defenses can begin to stand down. That is why walking works, not as punishment or correction, but as communication. If something in this explanation surprised you, whether it was the timing, the chemistry, or the idea that your body is protecting you, share that thought in the comments. Your experience may help someone else see their health differently. If this calm breakdown was valuable, tap like so more people can find science without fear. Subscribe if you want deeper explanations beneath the headlines. And when this video ends, consider taking a short walk. Not because you have to, but because now you know exactly what your body hears when you do.